Welcomes you all. This is a series of video lecture on differential calculus developed by P. Subramanian, Assistant Professor, Department of Mathematics, Government College of Engineering, Dharmaburi. In this series of video lecture, you are going to learn about representation of functions, limit of a function, continuity of a function, derivatives of a function, differentiation rules, and then finally maxima and minima of functions, which is a syllabus for Engineering Mathematics 1, Unit 1 Differential Calculus for Anna University 2017 regulation. What is function? Before going to the proper definition, just consider the machine. For every machine, there is some input and process. Depending on the input and process, it will produce some output. For example, the machine is oil extracting machine. The groundnut seeds may be given as an input to the machine. The machine processes with the seeds, it will produce groundnut oil as output. Suppose the machine is flour preparing machine. Rice may be given as an input to the machine. The machine processes with the rice, it will produce rice flour as output. Function. Function may be considered as a machine. X is given as an input to the function. The function processes with that x, it will produce f of x as an output. For example, f of x which is equal to 3x plus 5. Suppose x which is equal to 4 is given as a input, then the function is processed with that 4, which means 4 is multiplied with the 3 and then added with the 5, it will give 17 as an output. Let us look at the another one example. F of x which is equal to 2x square plus 1. Suppose x which is equal to 3 is given as an input to the function. The function processes with that 3, that is 3 is multiplied with itself and then multiplied with 2, then finally added with 1, it will produce 19 as an output. Let us see the definition of the function. To define a function, we need two non-empty sets. Let D and E are the two non-empty sets. A function f is a rule that assigns to each element x in the set D exactly one element called f of x in a set D. Here, the set D is called domain of the function. That is, the set of all possible inputs to the function is called domain. The number f of x is the value of f at x, and it is also called image of x under f. The range of f is a set of all possible images of x, and it is denoted by f of capital D. The function can be visualized in another way. Here in the image, D is one set and E is another one set. The elements from the set D are mapped by the function f to the element from the set E. Suppose x is an element in D, the function f is mapped the x with the element f of x. Suppose a is another one element in D which is mapped with the f of a by the function f. Let us see an example for the function. Function f of x which is equal to x square. Since every real number has its square in real number, therefore the domain is given as an entire real line. It is given by open interval minus infinite to plus infinite. Let us see the range of this function. Square of positive number is also a positive number. Square of negative number is also a positive number. Square of 0 is a 0. Therefore, the range of the function x square is given as closed interval 0, open interval infinite. The image of the number 6 is nothing but its square. 36 is the image of 6 under the function f of x, which is equal to x square. Representation of functions. Before going that, just think about the question. Draw the graph of y, which is equal to x square minus 4. This is a question from 10th standard geometry. Actually, what are the steps we have to follow to draw the graph? First, we have to compute the table of values for x and y. The values for x are chosen by ourselves. Here, I choose integers from -5 to +5 for the value of x. For each value of x, I have to find the value of y by substituting in the given function. Here, -5, 21 is a point on the xy plane. Like that, -4, 12 is another one point on the xy plane. Like that, each pair of x and y value is a points on the xy plane. The next step is each point is plotted on the xy plane. You are seeing in the first image all the points are plotted in the xy plane, and then all the points are connected by a smooth curve. You are seeing that in the second image. The curve is parabola, open upward and vertex at 0, -4. Why I am mentioned here these are things? Because these are all different ways of representing a function. First, the given equation is one kind of representation, and another one, table of number values for x and y is another kind of representation, and then the graph is another one representation. Representation of functions. Representation of function means communicating way or exhibiting way about a function to someone else. There are four possible ways to represent a function. First one is verbal representation, which is given by a description in words. For example, a parabola open upward, vertex at 0, -4 and passes through the points -2, 0 and 2, 0, which is the parabola just now we have discussed. Another one representation is numerical representation, which is given by the table of values, and the third one representation is visual representation, which is given by the graph, and finally algebraical representation, which is given by an explicit formula. Here I have given example for first one only, and last three already we have discussed. That's why I didn't give any example for here. Okay, fine. Thank you.